We talked about atomicity, we talked about isolation, we talked about what is really a transaction, which is really the most important thing here to understand before jumping into these properties. And then we really need to talk about consistency, which is one of the properties that were traded off in different platforms. When I say different database platform, I mean NoSQL versus relational versus graph. Consistency played a lot of role there. So some databases sacrifice consistency for speed and performance and scalability. I'm not going to talk about all that stuff, but consistency really, what do we mean by consistency? And in order to understand that, really, consistency are really twofolds. There is what I call consistency in the data itself, which represent the state of the data that is currently persisted. Okay, so what do you have actually in disk? Is what you have in disk consistent with the data model that you have? And we're going to talk about what does that mean. And there is another consistency, which I call consistency in read. So your data might be consistent on disk, but the reading of the data becomes inconsistent because you have multiple instances and they are slightly out of sync. So this applies to the system as a whole. So if you have like many shards or many partitions or many database instances, right? This is applied to the system as a whole. As a user, I don't care what database instance I have. I'm just issuing a read. That read better be consistent. And consistent in data is in a given cluster, in a given data instance, what is going on there? Is my data even consistent at that level, right? And let's take some examples. So let's talk about consistency in data. This is really defined by the user, right? This is something that the user defines, and by the user I mean the DBA really, or whomever builds out the data model in the database, right? And it really comes down to most of the time enforcing referential integrity and foreign keys in the database, right? I know some people coming from NoSQL don't have these concepts, but believe it or not, you do have referential integrity, whether you like it or not. You might have a document here that is referring to another document, and the moment there is a referential, there must be integrity in this reference effectively. We'll take an example that clarifies what that really means. And what also ensures consistency in the data is, guess what? Atomicity. If we had a crash while we debited one account and then restarted the database and the account remains debited half, right? We just lost $100 in thin air. That's an inconsistency in data. The data is just persisted wrong. It's corrupt. As we call it, engineers. There is corruption effectively. You corrupted your database effectively. That's pretty bad. Isolation also can result in inconsistency of data, because you could, we talked about that in the isolation lecture, where you can issue a read and you get a bunch of data back, right? But then you issue another read and you get different results based on your isolation level, and that leads to inconsistent result. So yeah, your data might be correct, but it is changing, consistently changing, and this change is giving you a different view. As a result, your view of the consistency is getting wrong. Here's an example. Let's assume you're building some sort of an Instagram data model here. So you have the pictures table, you have an ID, have a blob of the picture, binary large object, and the number of likes that this picture got. And then we have a tracking table that says, okay, John have liked picture 1, and Edmond had liked also picture 1, and John also liked picture 2. So you have certain referential integrities here. What is that? And it's defined by you as the DBA, whoever built this, because the number of likes here better be equal to the sum of these guys, right? Because if I do a select count from this table where picture ID equal 1 I better get 2 likes, and this should be equal. And this is basically the consistency in data. If this is inconsistent, then bad things can happen. Who cares about if you're out of sync with the number of likes? People give that up because really nobody cares. Nobody's gonna browse Kylie Jenner's 1.8 million like picture. Nah, nobody's doing that. But you get the point. This is one example, right? Another example is if you've seen an entry here to a picture that doesn't exist anymore, right? That's also inconsistency, right? And this is what we really mean when we talk about consistency in ACID transactions, right? We're talking about the ACID consistency here. Talking about the ACID consistency here. So I'll give you a few moments here to spot the inconsistencies in this data model. Take a look. So you might have already spotted picture 1 got 5 likes, but if you actually query the likes table, you can see that picture 1 only got 2 likes. So something got out of sync. This is an inconsistent referential integrity. Another referential integrity inconsistent data is you have Edmond liking picture 4, but if you actually want to get the actual picture in the pictures table, picture 4 doesn't even exist. So that's also an inconsistent result. So someone deleted this picture, but they didn't have a cascading event to delete the likes picture effectively, right? Leaving those effectively orphaned. Right? And you can have the database do these constraints, or you can have it do it at the application level. It's really up to you. But this is what we mean by inconsistency here. Is that what all it is? No, really. Consistency in read is another thing that can happen. Right? Let's take an example. You have a database system here, and you can look at this as a single database or multiple. Doesn't matter. But you're talking to one reverse proxy effectively that proxies that request to the backend. So you're updating value X, and now the database persists the value X, and now the next read after this thing commits must give you the value X. That's what it means by consistency in reads. You might say, Hussein, that's just obvious. Well, not all the time. Let's take an example. If a transaction committed a change, will a new transaction immediately see the change? That's what really boils down to, right? If I committed a change to a database and then I issue a read immediately and I don't see that change, then you are inconsistent effectively, because you just read something that is not really the value that you're supposed to get, and it affects the system as a whole. And what is an example that can get to? It's basically when you have a master or a main replica primary database, and they have a multiple worker database, right? And you're syncing the changes to the backend. And I have an entire section talking about replication, so check that out when you finish with this lecture. But effectively, as you write to the primary will sync back the changes to the replica. And if you read in the replica, you might get an old value. And that's what we mean by inconsistency here. So that's why it affects the system as a whole. Relational and NoSQL databases suffer from this kind of consistency. And even NoSQL suffers from the first type, if you think about it, right? It still does have this idea of inconsistent result in the persisted model. If you don't ensure referential integrity between your, MongoDB documents, you're going to get the same exact problem, right? Right? If you have users and a followers list, and what do you do? You have to ensure the referential integrity effectively that you set, the rules that you build. And then we come back to this marketing term that is called eventual consistency. It releases, which is really what means is, hey, I'm not consistent, but I'm eventually going to be consistent. I kind of torn on this term, to be honest. I'll give my thoughts in another lecture, but in a nutshell, most of the things that are currently not consistent will get eventually consistent. But that is very important to understand, because in the consistency of data, if your data is corrupt and referential integrity is broken, there is no eventual consistency coming out of that, right? Because hey, the data is just corrupt. You have 5 likes, but only 2 records that represent the likes. That is no eventual consistency coming from that, unless you have some sort of a repair post batch job that fixes that. But that's what we mean by eventual consistency, is only really to the reads, because if you continue issuing a read, you're going to get old values, but eventually you're going to get the correct value. That's what they mean by eventual consistency. And there is many terms here: eventual strong consistency and eventual weak consistency. And there is so much stuff you can go into this. I can really make an entire course just talking about eventual consistency. So it is valid in certain cases, but it's been invented to kind of differentiate between the corruption that can happen to your data effectively. So in summary, consistency are 2 types: consistency in the data, which are enforced by the referential integrity, right? Things that is persisted in the data, and there is no eventual consistency coming out of that, because your data will become kind of corrupt based on what you define by corruption here. And the different type is consistency in read. The consistency in read is when you update a value and then a transaction tries to read that value after it was committed, you get the old version, and that's an inconsistent result, right? So it was most databases heal from this kind of inconsistency by eventual consistency. So that means as the replication process completes, you will eventually get the final result effectively from that read, right? And this can be enforced by something called synchronous replication, which I believe I talked about in this course. Yeah, synchronous replication versus asynchronous replication. One is slower than the other, but one give you strong consistency and the other give you eventual consistency. At the end of the day, it's all comes down to what really you want effectively. And eventual consistency is something both relational databases and NoSQL suffer from. So that was basically a summary of the consistency. How about we jump to the final lecture, durability, one of my favorite.